Hi, welcome to Maths with Esomnofu. In this video, we are trying to solve this amazing Maths Olympiad problem we have on the board. That's 3 to the power of n minus 2 to the power of n must give us 65. Our goal is to find the value of n. Stay tuned and understand. For us to do this, by inspection, we won't allow n to be 0, okay? Because whenever we allow n to be 0, we are having 3 power 0, and you know anything raised to power 0 is 1. That will now give us 3 power 0 is 1, 2 power 0 is what? Also 1. So at the end, the left-hand side gives us 0, which is not what we want. So we won't choose it. So we take that n must not be equal to what? 0. Okay? By inspection, you can now see that since 3 power x is this, I can now write it as 3 to the power of n, then raise it to the power of 1, for instance, minus 2 to the power of n, all raised to power 1, is equals to what? 65. Okay? The reason why I put the 1 is that we can actually change it to anything. Okay? Because anything raised to power 1 still retains its value. So I can decide to make this 1 to be 2 over 2. 2 over 2. Okay? 2 over 2 is still 1. So instead of writing 1, I will use 2 over 2. So I will now have 3 power n raised to the power of 2 over 2 now. 2 over 2. Okay? Then minus 2 power n raised to power 2 over 2 is equals to 65. Please, the reason why I'm using 2 over 2 is that I want to take this to difference between two squares, okay? So now you can now remember the laws of exponents, which allows us that whenever we have a to the power of n raised to power n, m, we can write it to be a to the power of n, m. Or we can still accept it to be a to the power of m raised to power n. Since multiplication is commutative, you can take any positions. So since I have this now, I can now write this to be as 3 to the power of, instead of changing, I'll just change the denominator. Since when we have 2, we can write it as 1 over 2. 3 to the power of n over 2, then raised to power 2. Since multiplication is commutative, because if you multiply, the 2 still get the value. Then minus, I'll just do the same thing in the second one. 2 to the power of n over 2 raised to power what? 2. Okay? And that will be equal to what? 65. Okay? This now looks exactly as difference of two squares. So I can now say, let x to be equal to 3 to the power of n over 2. Okay? Then we take y to be equal to 2 to the power of n over 2. Okay? So if you have this now, we can now write this to be as x minus y squared is equal to 65. Okay? They are now taking the values of x and y. So this is clearly difference of two squares. In difference of two squares, we know that a squared minus b squared is equals to a plus b into a minus b. This is clear standard of difference between two squares. Okay? So if you have this now, we apply it here. That means x plus y into x minus y is equals to 65. Okay? So since we have this now, we are going to look at this particular term. That means two factors, the sum of two factors minus the product of the sum and difference of two factors gave us 65. By inspection, we are going to look at this 65. We are going to think of two numbers that exactly multiplies to be 65. Okay? So you can see that the numbers we look at is that when you multiply 13 and 5, 13 times 5 is 65. So our next step is to check which amongst these factors that adds up, you know that sum, since this is not a negative number, the sum is supposed to be greater. Okay? So we can see that 13 and 5 being the factor, the sum should be 13 and the difference should be 5, showing you that x is always greater than what? Y. Okay? So if we have that, we can now see that x plus y is equals to 13. Okay, then x minus y is equals to 5. This is now a clear simultaneous equation. This will be equation 1 and this will be equation 2. Once we have this, we are going to solve this simultaneous equation by elimination method. It's easier to eliminate y because you can see that the sign, they are different, the same number, but the sign differs. So we can decide to add the 2. If I add the 2, x plus x is 2x. And that's equals to, this is now eliminated, 13 plus this is 18. To get y, with x, we divide through by 2 and divide through by 2. If you divide by 2, you see that x is just 9. Put it back in any of the equation. I choose equation 1, which says that x plus y is equals to 13. If I put x to be 9, you can see that 9 plus y is equals to 13. Okay? For us to get the value of y, we subtract 9 from both sides. That gives us that y is equals to 13 minus 9. And 13 minus 9 is 4. Okay? But remember, we've said that x is this and y is this. So for us to get those values needed, you can now see that for x, x is equals to 9 and x is equals to 3 to the power of n over 2. So what do we do to get the value of x? We have it that 3 to the power of n over 2 is equals to 9. And you know basically that 9 is 3 squared, right? Please subscribe, like, and share. 9 is 3 squared. So we can now take this to be that 3 to the power of n over 2 is equals to 3 squared. Since the bases are now equal, we have to equate the powers, showing us that n over 2 is equals to 2. Okay? So to get the value of x, we just have to cross and multiply. So you see that n is equals to 4. Okay? So for us to check for the other side to know whether we are right, we have it that 2 to the power of n over 2 is equals to, here is 4. 4, right? So what do we get? You can now see that we have it to be 2. That's what? 2 to the power of n over 2 is equals to 2 squared. The bases are equal. We simply have to equate the powers. That means n over 2 is equals to 2. Okay? So for us to get the value, we just have to cross and multiply. If we cross and multiply, n is equals to 4. So you can now see that n is consistent in both sides. So the value of n can only be 4. Okay?